Hello everyone and welcome to a brand new Python tutorial series. So in this series, I'm going to be teaching you the basics and fundamentals of the Python programming language, and we're going to immediately be applying those into our own project/game. So the idea behind this series is that not only do I want to teach you these concepts, but I want us to actually apply them into a project so we can see where they're used and how we use them. So at the end of this series, you will have a complete finished game that you will be able to show off. And the way that we're going to be making this game makes it really extendable and flexible so you can add your own stuff and really customize it as we go through. So before I say anything else, let me just note that this tutorial series is really for complete beginners. This is for people looking to get up and running in Python as fast as possible. And in these next 3 videos, we're going to be learning a bunch of different skills and syntax. And then by the end, we're going to have that complete project. So let me show you an example of what this project could look like. Keep in mind, this is just like kind of a smaller version of what it might be. This is very flexible and we might make it a little bit different as we go through. So let me run this. And the type of project that we're really making here is a choose your own adventure game. Now, in my opinion, this is one of the best projects you can work on as a beginner because of how flexible it really is. So let me just show you what it is, and then you guys should get an idea pretty quickly of why this is a great project to work on. So you can see it says, welcome to my first game. What is your name? I'm going to put Tim. What is your age? Let's put 19. It says, you are old enough to play. Do you want to play? Let's type yes. It says, you are starting with 10 health. All right, let's play. First choice, left or right? Let's decide to go left. You can see that what's kind of happening here is these first steps we're just setting up in the game, but now it's going to give me a bunch of decisions to make. And based on what I choose at previous steps, it'll give me different decisions. So I decide to go left here. It says, nice, you follow the path and reach a lake. Do you swim across or go around? What do we think? Do we go across or go around? Let's go across. So I go across. It says, you managed to get across, but you were bit by a fish and lost 5 health. You notice a house in a river. Which do you go to, the river or the house? So let's decide to go to the river, and let's see, you fell in the river and you lost. So hopefully that gives you an idea of how this works. Let me run it one more time and I'll show you that there's different options that will pop up based on where you decide to go. So Tim, 19, yes, you were starting with 10 health, let's play. If I decide to go right, notice that immediately I just lose, right? So there's all these different paths and kind of decision trees and branches that we can go down. And it makes this game really cool because it's pretty simple to create, obviously, for beginners. That's what we're going to be doing. But it's also really cool and really flexible, and you can kind of make whatever you want out of it. So with that being said, we need to get our coding environment set up here. Fortunately for us, we're actually going to be using a platform called Replit. So it's repl.it, so repl.it. This is an online browser-based coding environment. And I'm just going to walk us through how we can actually set this environment up and get started right away without having to download or install any software. So as I mentioned, we're going to be using an online coding platform called Replit. So it's spelt repl.it. That is the website URL. I will link that in the description as well. But this is a free browser-based coding environment. So what that means is that the only prerequisite for this series is that you have a browser and you have internet connection. So to get started, you need to go to this link and obviously sign up if you don't have an account or log in. So I'm going to log in, but when you sign up, it's going to ask you to input your favorite programming language. I would recommend you just select Python. It doesn't matter, but that's just something that you will have to go through to get this set up. So I'm going to go here to New REPL, and I'm going to select Python and give this a name. Now the name that I'm going to give mine is First Game. Feel free to name yours whatever you'd like. And then just notice that this will be a public REPL, which means it'll show up on your profile and everyone can see it. If you want to go for private REPLs, that is kind of a premium feature, but I wouldn't worry about that. We're not making anything that we care if someone steals. So let's go create REPL and let's boot up into our first environment. All right, so the first important thing that we need to understand is how we can actually print things and get things to show up in the console. So before, remember how when I ran the code, we would see some kind of output, right? It said like, do you want to play the game? Or it would tell us some kind of message. So how do we actually go ahead and do that? Well, the first command we're going to learn in Python is known as print. So all of the things I'm about to show you are pretty much called syntax. Syntax is really like the grammar of a programming language. It's like, where does the period go? Where do we have parentheses? It's just the structure, the way that we write the code. And if you hear me use the word syntax, that's what that means. But the syntax to print something out in Python is really simple. We just put print. We put an open parentheses and a close parentheses, and then inside of the print statement, we put a set of single or double quotation marks, and inside of these quotation marks, whatever we want to print to the screen. So you can think of it as like we're printing a quote, right? If you wanted to say that, although this is going to be referred to as something else that I'll talk about in a second. And whatever is inside of these quotation marks, that text will just show up in the console. So if I say hello world, the classic first program, then let's run, and we get hello world popping up in the console. So this is the easiest way to print something out. There's a bunch of other ways we can use this statement, but again, it's just print, open parentheses, and then you need these double quotation marks or single quotation marks. Doesn't matter which one, but make sure the set is obviously the same, so you don't go like single quotation mark, double quotation mark, that won't work. And then whatever inside of here that you want to print out. So let's apply this now immediately into our project. Like I said, the first thing we want to do in our choose your own adventure game is probably introduce the user or whoever's playing to the game, right? So what I'm going to say is welcome, if I could type, welcome to my first game. Now you guys can obviously put whatever you want inside of here. I'm just going to say welcome to my first game. Maybe you want to be more creative and put the name of your game, although we might not even know what that is yet, but don't worry, we can always go back and change that. All right, so print welcome to my first game. Great, so that is the print. Now what I need to talk about is variables and data types. Now this is a really important concept. Now this is going to be a little bit more theoretical. It's hard to apply this, but we definitely need to understand this. So inside of Python, we kind of have four main types of information or data. So in our programming languages, we have data, right? That's information that we're maybe going to store, that we're going to pass around, that we're going to manipulate. If you think of an application where we're just counting, say we're just counting up, well, we're going to have some notion of like what the count's at, right? That would be an example of data that we're going to store in our program. There's lots of examples of this, but this data that we have has different data types. And there's kind of four main ones that we need to cover. So the first one is string. The second one is int. Then we have float, and then we have bool. Now a string, which is represented by str, I'll actually just type out string here so you can see it fully, is anything wrapped inside of double quotation marks or single quotation marks. So like hello is an example of a string. Hi is an example of a string. 989 is an example of a string. Anything that's inside of double or single quotation marks is a string. And strings are just a collection of characters. They're just text, right? And usually we're going to use strings just to print stuff out to the console. There's a bunch of other use cases of them, of course, but for now, that's what we can kind of think of as strings. Next, we have ints. Now, ints are any whole number. So just the number, they're not wrapped in quotation marks or anything like that. Just any whole number. It could be negative as well. That's totally fine. It could be a really big number. Any whole number that does not have any decimal points is an int, otherwise known as an integer. So that kind of follows our understanding from math. So hopefully that one makes sense. Next, we have float. Now a float is any number that has a floating decimal point. So if I have something like 6.0, that's a float because we have a decimal point and then something after it. If we have a number like 7.5, that's a float. Negative 9.8, that's a float. And negative 100.0, again, a float. So even if it's a .0, which technically is still a whole number, right? Because 100.0 is a whole number. If it has this decimal point anywhere, it's considered a float. And lastly, we have a Boolean. A Boolean is one of two values, true or false. So these two exact things that I typed, nothing different about them. So the capital T and the capital F is very important. If you see one of these two things, and you can see they're kind of highlighting in blue, telling us they're a fancy thing in the language, then those are Booleans. So I'll leave this in what I'm going to call a comment, which is actually interesting to show you guys. So if I do 3 quotation marks, and then I do another 3 quotation marks like this is actually what represents a comment or a multi-line comment inside of Python. This isn't super important to understand, but what this means is that whatever I wrap inside of these triple quotation marks, and I can put these anywhere I want, this will just be ignored by my program. So right now we're going to print this, right? And that's going to work fine. But if I were to wrap this inside of triple quotation marks, we can see it kind of gets commented out. And now that means our program is just going to ignore whatever's inside of these sets of triple quotation marks. So if I run my program, I no longer am printing that out. And there's actually another way to make a comment as well, and that's to use a pound sign. And what this does is simply comment out one line. So it just comments out whatever comes after it on the line. This sometimes is useful if you just want to comment out one line, not a whole block of code like I've done here. So I'll leave this down a little bit at the bottom of the screen, and now we'll actually start writing a bit more code. So there we go, we understand data types. Now we need to talk about variables. So variables are essentially a way of storing data. Now, you can think of a variable like in math, right, where we had like x equals 5, x equals 7. That's a really similar way that they work here in programming. And to make a variable, I'll just show you a few examples. It's quite easy. You simply pick a name for your variable. In this case, let's say x. You put an equal sign, and on the right-hand side, you put some data type, or you assign it equal to another variable or some other things that we'll talk about later. But essentially, you put something on the right-hand side that you want to be stored in the variable. So in this case, maybe I want my variable x to store an int, which is the value 5. Awesome, there we go. That's all I need to do to make a variable x that stores the value 5. Now, if I actually go ahead and write another print statement here, which is totally valid, we can write as many print statements as we want. What's going to happen now is we're going to print welcome to my first game. We're going to read the next line because we do read code top to bottom most times, other than certain circumstances. But you can think that when we execute the program, we read from the top. So left to right, top to bottom, that's just the way it works. So then we do this. We set x equal to 5, and now what I'm going to do is actually print x. Now notice that I didn't surround x in quotation marks. The reason I didn't surround it in quotation marks is because it's a variable. So a variable is actually something that I can print totally fine right inside of the print statement, because I'm not trying to print out the letter x, I'm trying to print out whatever the value is that's stored in the variable x. So in this case, I'm going to print out 5 because x equals 5. So if I run this, let's have a look. Welcome to my first game, 5. Awesome, there we go. We now kind of understand variables. So of course, I can store other things in variables too. I could store the value true, right? This would be considered a Boolean or a bool. Let's have a look at this now. So now we print out true, and that's kind of the basics on variables. They can store things. So you set a variable name equal to something. Now there's a few rules with our variables. The first has to do with their naming. So when we create a variable, all we kind of have to do is just type something out and set it equal to something else. But the thing that we type out, or the variable name, has to follow these rules. It can only contain lowercase and uppercase letters, underscores, and numbers. So it cannot contain any special characters other than an underscore, and it cannot start with a number. So something like hello1 is totally valid. Hello1 equals 9. Awesome. Hello1 underscore, totally valid. But as soon as I go 1 hello, note, you can see we're getting this red squiggly line. Not allowed. We cannot start a variable with a number. But I can go ahead and do something like that. That's fine. I can put a number in between. Just follow those rules. And typically, you don't really use numbers in your variable names. You're just going to use some text, maybe uppercase and lowercase letters. And in Python, if you want to do a space, because there's no spaces allowed in variable names, just use an underscore. So something like hello underscore world. This is the convention for making variables. You separate anything that's kind of 2 words using an underscore. So let's say hello equals 9, right? And then we could print out hello and we'd get the value 9. Now, of course, we can make a lot of other variables too. We can say the variable yes equals, and maybe it's equal to the string hello. I can actually use something crazy and say hello equals yes. Now, what that's saying is that hello, this variable hello, is equal to whatever is stored in the variable yes. So in this case, hello will be equal to hello. Funny, right? But that's how that will work. So we can assign variables to other variables. We can do something like hello equals hello plus 9. Totally fine. And in fact, what I'm going to do now, excuse me, is I'm going to try to actually show you how we can ask the user for some input and store what they type in a variable. So now we're on to the next part, which is getting user input. So to get user input, what that means is that in the console here, we're going to let the user type something in. Because right now, if I run this, you see that it says, welcome to my first game, and then the program kind of just ends after that. Ideally, I would like to ask the user what their name is and store that in a variable. So let's go ahead and do that. I'll just print it out, and then I'll talk about how this actually works. So I'm going to make a variable called name. The reason I've called it name is because it's going to store my user's name, and usually we want to name our variables something that are meaningful. And I've set that equal to input, and inside of this here, I'm going to put a string that is the question I want to ask the user. So what is your name? Question mark. Now notice I did a little space at the end. Try to think of why I would have done this space in just a second, but just keep in mind I did do this space. Just remember that. So now what I'm going to show you is what happens when I run this program. So let me move this over here. Let's zoom in. Welcome to my first game. What is your name? Let me type Tim. All right, so I typed Tim, and notice that here the cursor is going, and I can type stuff right into the console. That's because I used this input key. So what this says, if I have input and then I put what's known as a prompt inside of here, then whenever we read this line of code, so when our program actually reads this, it will say, okay, print this out and then wait for the user to hit enter. So let them type something whenever after we print this out, so on the same line as what is your name, and then as soon as they hit enter, we're actually going to take whatever they typed and we're going to store it in the variable name. So if I type Tim like that, what actually ends up happening, and I'll have to zoom back out here, is that the variable name is going to be equal to Tim because I typed Tim. And then if I type Joe, the variable name is going to be equal to Joe because I typed Joe. So to prove that to you, let me print out name, because we can print out variables, right? So this variable should equal the name we typed in, and then let's just print it out. So let's have a look. What is your name? Tim. And there we go. It prints out Tim. Now notice I'm not just lying to you here. If I type Joe, it prints out Joe. So we are grabbing and storing the user's name by using this input tag. Now the next thing I actually want to grab from the user is their age. We're going to do a cool thing here that makes sure they're a certain age before we let them play the game. So let's say age equals input. And then what do you guys think we should put inside of here? Well, have a think about it for a second, because I am about to start typing. Pause if you need to. But I'm going to put, what is your age? And now what's going to happen is we're going to ask the user for their name. Then we're going to ask the user for their age, and they're going to type both of those values in. So let's run this, and let's say, what is your name? Tim. What is your age? 19. Boom. Stops. There we go. Now age will store 19 and name will store Tim. So if I want to show you those two things, what I can do is actually print them out. And I'm going to show you the last thing kind of for this video is how we print out multiple things on the same line. So let's say I wanted to say something like, hello, Tim, you are 19, right? So I want to print their name and then I want to print their age, and I want to combine that with a few other words just to kind of welcome the user. Well, how do I do that? There's a few different ways to do it, but the way that I'm going to show you is kind of the most common, and it's something like this. Essentially, you can separate anything that you want to print on the same line with a bunch of commas. So I can do something like hello, comma, name, and what this will do is print out the string hello that we've already talked about. We understand we can print out this and it'll show the text. Then we'll print out whatever the variable name is, so whatever's stored inside of there, and this comma will automatically put a space in between them. So hello space name, where name will be equal to whatever we typed in. Then I can say, hello Tim, you are, and then I'll put age, comma, years old, like that. And there we go. That's all we need to do to print out hello, whatever their name is, you are, whatever their age is, years old. So we've just separated them by commas, and now it'll print all those things out. So let's have a look here. Let's go Tim. 19. Hello, Tim. You are 19 years old. And let's say, actually, let's just leave it like that for now. I got rid of some of the comments I had below, and we've just left this now. And what this program does at this point is just welcomes us to the game, asks us for our name and age, and then prints out the name and age of the user, so whoever typed that in. Now, what I want to do here, and there's a few things we're going to have to learn to be able to do this, is check if the user is old enough to play our game. So I want to check if they are, older than 18, or if maybe this game is PG-13 or something, right? That's what I want to make sure that they're the correct age before we actually prompt them, do you want to play? So before we let them start playing, we want to check that they're older than a certain age. So how do we actually do that? Well, that leads me to an important thing called conditions. So first, we need to talk a little bit about arithmetic. So arithmetic is just math. There's four main operators in, or not four, sorry, there's actually more than four. There are some main operators inside of Python that allow us to do arithmetic. Arithmetic is just math, right? So we have the asterisk, the star, the plus, the minus, and the modulus. Now there's also a /2, which we'll talk about very briefly. And these are important. These are the operators for math operations. So the asterisk is multiplication. The slash, the forward slash is division, the plus is addition, obviously. The minus is subtraction. The percent sign is actually modulus, which gets us the remainder of a division, I'll show you. And the / stands for integer division. So these are the main operators that we can use. And I just want to show you how we can do some basic math, just so you have that skill if you need to use it. We may not use it in this kind of project, but it is something important, so I figured I'd show it. So let's say we have the variable x equals 9 and y equals 8. What do I do if I want to add x and y? Well, I could do x plus y, right? That technically would add them, but I want to store that addition somewhere else. So just something important to understand is that when you do something like x plus y, this does not assign x to 17. It might make sense, right? If you say, oh, x plus y, you might be saying like, oh, add y to x. I could understand why that may seem logical to some people, but this doesn't really work in programming. When I do this, all that happens is this gives me a value 17, but it doesn't get stored anywhere. So what I need to do if I wanted to say add the value y to the variable x is do something like x equals x plus y. Now I'm going to say the variable x is equal to whatever the previous value of x was plus y. That will actually do that addition for me. Now, same thing if I do this. So plus equals is a shortcut for what I just showed you. The people that made Python know that a common operation is to add one variable to another. So rather than having to rewrite, x equals x plus y, you can just do x plus equals y, which stands for x is equal to the addition of x plus y, right? That's pretty much what that's doing. So that will assign the value of 17 to x if you did something like that. Now, when you're doing arithmetic, the order of operations apply. So let's say I have a variable z, and I said z is equal to 9 times, or not 9 times 8, x asterisk y plus y. Well, the order of operations that we know will follow, which means this multiplication will happen before this addition. Now, let's say we didn't want that and we wanted to, change the order of operations. Well, we could use parentheses like we would in any other math or any other programming language or math or whatever, and then this will follow. So we will do the parentheses first. Now, these are the common operations, right? So this is multiplication, that's division. Now I'll just show you the kind of 2 or 3 ones that you might not know. So the exponential operator, which I actually haven't shown it, is the 2 asterisks. So when you do 2 asterisks, that stands for raised to the power. So x raised to the power of y plus y, so whatever that would be, so 16, I guess. And then the other 2 operators I wanted to show you were the mod operator and the integer division operator. So the mod operator, what this does is get the remainder after division. So if I say x mod y, this is actually equal to 1. Now, the reason this is equal to 1 is because the way you do this is you say, okay, how many times does 8 go into 9? How many times? It goes in 1 time, fully, right? It goes in 1 full time. What is the remainder after you take that 8 out of the 9? Well, it's 1, right? So if you do 9 divided by 8, you get 1 point something, but really it's 1, remainder 1. That's the way you can think of it. So like if I had, say, 5 and 2, then the mod again would be 1, because you say, how many times does 2 go into 5? Well, it goes in 2 times. Okay, so what is that? That's 4. Let's take 4 out of 5. Okay, what's the remainder now? Well, there's 1 left, so that's remainder 1. It's pretty straightforward. That's how that works. Whenever you do something mod 1, obviously the remainder is going to be 0, because 5 can be divided by 1 perfectly fine. And if I did something like 0 mod 1, then that would be equal to 0, because 0 does not go into 1 at all. So what's the remainder? 0. I hope that makes sense. That's the mod operator for you. It's not super important, so I won't spend too much time on it. And then we have the integer division. So integer division is 2 slashes, and this is kind of the opposite of mod. It doesn't give you the remainder after division. It gives you the whole number division, or the whole number quotient, I think is what it's called. So if I do 5 divided by 2, how many times does 2 evenly go into 5? Well, it goes in twice. So the integer division of x by y is going to be 2. Right? And then if I change this to 7, same thing. So how many times does 2 go into 7? Well, it goes in 3 times, so the integer division would be 3. That is the basics of those mathematical operators. Just in case you need to use them, I felt they're important to show. Now, with those operators, there's also a bunch of other operators too. We have a less than, we have a greater than, we have a less than or equal to, a greater than or equal to, an is equal to, and a not equal to. Now, these are what are known as our comparison operators, and this is how we actually check equality between different things. You might imagine that it's actually pretty important for us to, for example, check if someone is older than a certain age. So if we wanted to check if the person's age was older than 14, we would have to use one of these operators to do that. Now, this is where we start talking about Booleans. I'm trying not to go too fast here, but again, I really do want to get to the project, but some of these things are pretty fundamental to go through. So actually, can I type in here? Let me just see if this works. Perfect. So I'll actually do some stuff in the console for us. And don't worry, I'll zoom in quite a bit so you guys can see this. All right, so zoom, zoom, zoom. Okay, and now I'm just going to do a few examples of what we call conditions or Boolean expressions. So remember I showed you that type before that was bool, right? That doesn't matter that you see that, but it was a bool. And those were the values true or false, right? So when we use these conditional operators, so that greater than, that less than, the less than or equal to, the greater than or equal to, the is equal to, the not equal to, when we use those, whatever we put on the left-hand side and the right-hand side will be compared using that operator, and we'll either get a true or false value. So if I said something, and this is like a really common example, 3 is less than 4. Well, what do you think, right? If I tell you this is going to be either true or false, so it's going to be one of those Boolean types, what do you think this would be? Well, of course that's true because 3 is indeed less than 4, right? And then if I switch this around and I say 3 greater than 4, well, we get false because 3 is not greater than 4. So this is the basics on how these conditional operators work. And I can do something like, 45 less than or equal to 45. Now, is this true or false? Well, that's true because the way that this works is it checks if the value on the left-hand side is less than or equal to this value, right? And that's kind of the basics on how some of these things work. Now, let me see. Can I clear? There we go. Awesome. Let's hit enter here and see if we can start typing. Now, the important ones that we want to go through, though, are comparing for equality. That's something we want to do a lot of times. So comparing numbers using the less than and greater than signs, that's pretty easy. I think that makes sense to most of you. It's either true or false, so you can read it and pretty well figure it out. But sometimes when we have checking for equality, it can be a little bit different. So if I have something like 5 equals 5, what this says is 5 equal to 5? So when I did before, right, when we made a variable, we could do something like x equals 5. And that is an assignment. That means we're assigning 5 to the value x. But if I go x equals 5, what I'm asking is x equal to 5? The 2 equal sign is like a question mark almost, like, is this true? Give me the result. Whereas the 1 equal sign is an assignment. You're telling x that, yes, it is equal to 5. So if I say x equals 5, we get the value true, right? And in fact, what I can do is make a variable called y. Let's say y equals 5, and I could say x equals y, and we'll get true. All that happens when I use the variables here is it will just check what their value is. So we've assigned their values here, and it will compare their values and tell me if that's true or false. So that is the very basics of how we can use that equality. So equals, and then there's one more, which is the not equals to. And what this does is tell us if two values are not the same. So whatever the result of the 2 equal sign would be, it's just reverse. So in this case, x is equal to y. So since they're not equal to each other, or since they are equal to each other, the not equal to will give us false, right? So if we look at false, it says no, these actually are equal to each other. So we're getting false for the not equal to operator. I hope that makes sense. Now, lastly, we can compare strings, right? So I can do something like hello equals hello, and boom, that works fine. That's totally true. But what happens if I try to do this? Hello equals 5. No, we cannot assign. Oh, sorry, not hello equals 5. Hello equals 5. What am I saying? We get the value false, right? So when we compare different types, like an int and a string together, obviously those aren't going to be the same. And what if I actually go ahead and do something like this? 5 equals 5. Well, that's false too. So even though these values are technically the same, since this is a string and this is an int, we're going to get false. So that's very important that when we're checking things, they are the same type. Because if they're not, then we're going to get errors like this where they might actually be the same value, but it's not showing up as the same value. So I'm hoping this is making sense. Of course, we're going to go through more examples. But last thing I'll show you is that when I do like hello equals hello, do we think this is going to be equal or not? If you have a look at it, yes, no, what do you think? Let's run this. We get false. So whenever there's any capital letters, that really matters. So just make sure you understand that. The types really matter, and the capitalization matters as well. And I'm going to show you ways that we can deal with that, because you could imagine, like, if we're checking to see if the user types something in, we want them, if they type it in with a capital letter or not with a capital letter, we still want that to work, right? We still want to check and see that that value is what we want it to be equal to. So anyways, that was kind of the theory that we needed to go through. Now let's get it into the project and start working on it. Apologize if that was longer than anticipated. All right. So what did I want to do? I wanted to check if the user's age was over a certain value. So what I need to do is I need to write an expression that pretty much checks if age is greater than, some value, right? So let's first of all check this. Let's print, and we're actually going to go and we're going to say is underscore older. So I'm going to make a variable called is older. And I'm going to set that equal to age, and we'll say age greater or equal to 18. So what this is going to do is it's going to assign whatever the value of this expression is, so this will either be true or false, to the variable is older, and then I'll print is underscore older, just like that. So this will just tell us true or false. And let's actually have a look at what we get here, because it might surprise you a bit. So let's run this, and let's have a look at what we get. So let's go name Tim, age 19, and we get a bunch of red text. This is our first red text that we've seen. So this is an error message. I did this purposely, and I want us to read what actually happened here and see what line it happened at so that we understand what happens when we get an error message. So if you see this red text, don't worry. It just means you've done something wrong. Could be, well, it definitely is your fault because you typed it, but you can definitely figure out what's wrong just by reading through this error message quite easily. So you can see it says traceback, most recent call last. Don't worry about this gibberish. If it doesn't make sense, that's fine. What you're really looking for here is the line number, the actual line where this thing went wrong, and then what the error was. So in this case, it says file main.py, so that's the file we're working in. Line 7, okay, so line 7. This is the expression, so is older equals age greater than or equal to 18. And then type error, greater than or equal to, is not supported between instance of string and int. So what that actually means is that this age variable here is a string, and this here on the right-hand side is an int. So I cannot compare if the string, because imagine if I had a string like, hello, I can't say hello greater than or equal to 18. That doesn't make any sense. I can't do that. And since age is a string, we can't do that. But why is age a string? Didn't I type in 19? That's weird. Well, by default, whenever you type something in using input, it automatically comes in as a string. So even though I typed in 19 like this and I didn't put the 2 quotation marks around it, it automatically looks like this inside of my program. That's just the way it works because this input doesn't know what we're going to type, right? So it has to just assume it's going to be a string because a string can hold anything inside of it so long as it's wrapped in the quotation marks. So that's why we have to do that. So anyways, that's what we do. So we now need to actually find a way that we can convert this age to an integer. So we need to take that string value and we need to convert it to an int so that we can actually compare these two things. So the way that I do that is I write int and then I wrap the variable age with this int. So I say int, open bracket, close bracket around age. Now that says whatever this age is, so whatever number this age is, because in this case it's a string that's 19, let's just strip out the number from that. So get rid of the quotation marks and make this an int value. So now if I say is older equals the int value of whatever the age is, so take those quotation marks away, just make it an integer, and check if that's greater than or equal to 18. So this will work now. So let's actually have a look at this. So what is your name? Tim. What's your age? 19. Hello, Tim. You are 19 years old. And then it says true. So that totally worked and that was fine. We were able to convert the string that we typed in into a number. So just keep that in mind. If you're asking a user to type in a number, then you want to make sure you convert whatever they typed in to an integer so that when you want to compare it or you want to use it, it's actually an integer value. And there's another way to do this. I can type int around the input statement up here. And the reason this works is because this is pretty much doing the exact same thing we're doing down here, except now we're going to actually assign an integer value to the age variable rather than just convert the age variable later on to an int. So it takes the input, whatever the user types in, and then immediately just converts it right into an integer. And now I can remove this. And this will still work because this is being converted to an integer immediately. So let's run this. Let's say, what is your name? Tim. What is your age? 19. And now we get, hello, Tim, you're 19 years old. True. All right, so we've covered a lot of stuff. There's one more thing to go through, and this will be kind of the most exciting thing we do so far. So I'm excited to do it. And this is called the if statement. So right now we just printed true, but ideally, I want to give the user some different messages based on if they're old enough or not, right? I don't want to just print out true. So how do I do that? Well, this is where we use the if statement. So you've seen that we make these little conditions, right, by using these conditional operators, and these are either true or false. Now, the reason we use these is because we can use them inside of an if statement. So actually what I can do is, I don't need brackets, but I'm going to remove this variable is older, and I'm going to take this age greater than 18, and I'm just going to kind of code something out, and then I'll talk about how this works. Oops, if we could get this type in right, you are old enough. Okay. So what this is saying is this is an if statement. What the if statement does, it says if the condition here is true, do this. That's as simple as it is. You literally read it like plain English. You write the keyword if, so if. You write some condition here, whatever you want to check, but this needs to compare or it needs to be true or false. So this needs to evaluate to true or false. And then you put a colon. It's important you add the colon. Then down here you do a tab, right? So you tab in, so one indent level, and whatever's inside of this indented block underneath the if statement will happen if this condition is true. If it's not true, it will simply skip whatever's indented and just keep moving on in the program. So I'll just show you because I'm going to print this twice just so that this makes sense. So I'll print this 2 times. So now if the age is greater than or equal to 18, we'll print you're old enough twice. So let's run this. And let's go ahead. What is your name? Tim. What is your age? 19. Hello, Tim. You are 19 years old. You are old enough. You are old enough. So that is exactly how that works. Now, there's one more component to show to this, and I think that was easy enough. Hopefully that makes sense. It's just if you write some condition here, and then if that condition is true, you go ahead and you do whatever's in this block. Now, what about if they're not older than 18, right? So if I run this again and I say, what is your name? Tim. 19. Hello, Tim. You are not. Oh, well, I should have selected an age that was younger. So let's do Tim 17. Hello, Tim. You are 17 years old. What if I want to tell them that they're not old enough to play? Well, I could do another if statement, right? I could do if age is less than 18, and then I could print that out. But there's actually an easier way to do this, and this is using an else. So this else statement kind of combines with the if. And whenever you write an if, you have the option, you don't have to, but it's up to you if you want, to put an else statement afterwards that tells you what to do if this condition is not true. So essentially this is saying, if this is true, do this, otherwise do this. And now we're going to put another indented statement, and we're going to say, you are not old enough to play, ... So let's try this now and just see how this works. So let's go Tim. Let's go 17, and now it says, hello, Tim, you're 17 years old. You are not old enough to play, whereas before it told us we were old enough to play. So that is the basics of the if statement. So we have the if and the else. Now I'll show you one more thing with the if statement, and then we'll kind of start the very beginning of our game and then continue the rest of it in the next one. But we've almost learned pretty much everything we need to know. So now we're going to go else if. So else if is another statement that we can use, and the way that this works is essentially we're checking for one more thing. So let's say we had 3 options, right? Maybe if they were younger than 14, they just couldn't play. If they were older than 14 but they had a parent with them, they're allowed to play. And if they're older than 19, they could play alone. Maybe those are the 3 options we have. So what I could actually do is I could change this around a bit, and I can say if age is greater than or equal to 18, you're old enough to play. Then I could say else if. So if this isn't true, but this is true, so what I put here, age is greater than or equal to 14, then what I can do is print, you can play with supervision or something. Supervision. Okay, so now what I'm saying is, what is this? Sorry, not else if. This should be elif. I'm coding another language here. Sorry, not else if. Elif, E-L-I-F. Apologize about that, but elif. Then you put the condition, and then whatever you put in the indented block below that will happen if this is not true, but this is true. So I hope that makes sense, but it goes like, check this. If it's true, do this, and skip the rest of it. And then if this is not true, check this. If this is true, do this, skip the rest of it. If this is not true, go into the else and do this. That is kind of the way that this works, and you can actually put multiple elif statements underneath each other. So you can do if, elif, 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 else, and these again are all optional, but just remember that the else always comes at the end, the elifs go in between, and that you can have as many of them as you want, but you don't need to. So that's an important thing, but let's just have a look at what happens now. So let's say, what is your name? Tim. What is your age? Let's do 15. And now it says, hello, Tim, you're 15 years old. You can play with supervision. So that is the basics of the if, elif, else. Now let me scrap this. Actually, I won't scrap this, but I'll get rid of the else if. And let's leave it at this for now, because it's going to say, okay, actually, we'll add one more thing to finish it up. If age is greater than or equal to 18, print you are old enough to play. And now what I want to do to wrap this up is ask them a question. Do you want to play? So if they're old enough to play, let's ask them if they want to play. And let's do that inside of here. So only if they're older than 18 and they're old enough to play, then I will ask them if they want to play. Otherwise, I'm not going to. So inside this if statement, I'm actually going to say, wants underscore to underscore play. You can name this variable anything you want. I just like to make mine descriptive. And I'll say input, do you want to play? Now I'm doing a space here just so that when they start typing, and I forgot to mention this in the last video, when they start typing, it doesn't get squished right beside the text. So I just add a space afterwards and it makes it a little bit nicer. But wants to play equals input, do you want to play? And now I'm going to check if they want to play. So I'm going to say if, and I will actually say wants to play equals yes. So if what they type in is equal to yes, then print let's play, exclamation point. So I know that was a lot. Let me zoom out a bit here just so we can read this a little bit easier. And now let's run this program for the last time before we wrap up this video. So what is your name? Tim. What is your age? 18. Hello, Tim. You're 18 years old. You're old enough to play. Do you want to play? Let's type yes. And it says let's play. Awesome. Let's run this one more time. What is your name? Tim. What is your age? Let's go younger than this time. So let's go 17. Hello, Tim, you're 17 years old. You're not old enough to play. So I hope this is starting to make sense, but I'll just give you a really quick summary. So we welcome the user. We ask them for their name and their age. We convert their age right away to a number so that we can actually compare it later on. We then say, hello, whatever their name is. You are, whatever their age is, years old. We then check how old they are. If they're older than 18, we tell them that they're old enough to play, and then we ask them if they want to play. If they say yes, so if they type in the string yes, we print let's play. Otherwise, we tell them they're not old enough to play. And that is the very beginning of our game. And I hope you can see what's kind of going to happen here in the future, right? So when they want to play, now what I'm going to do is inside of here, I'm going to ask them their first question. So I'm going to say, okay, your first decision is, do you want to go left or right? Or we'll make something up. And we're going to keep kind of chaining inwards and nesting if statements together just to make all these blocks with all these different decisions. And you're going to see it's going to get pretty intricate pretty quickly, but I think this is pretty cool. And right now you've learned almost everything you need to know to make this full game. So the first thing I'm going to do is just kind of recap and just kind of run this program and see what we actually have so far so we know where we're going from here. So welcome to my first game. What is your name? My name is Tim. What is your age? 19. Hello, Tim. You are 19 years old. You're old enough to play. Do you want to play? Let's type yes, like that. And boom, it says let's play. Awesome. Now I just want to show you a case that we may not have considered yet. So if I do Tim 19 and do you want to play? Now what happens if I do something like this? So Y capital E S. Well, I'll give you guys an opportunity to take a look at it. If we have our condition here, right? So we say wants to play equals input, do you want to play? And then we say if wants to play equals yes, let's play. So do we think when I type Y with a capital E and then S that this is going to work? Well, no, it's not. So if I do this, it actually doesn't, this if statement is not true. This condition is not true, and therefore this doesn't run. So how can I actually go about and fix that? Well, this is the first thing that I wanted to show you and that I guarantee you guys will find very useful for the rest of this kind of game and anything in the future. There is this method, and it's called a method. It's not that important. You don't have to understand what that means, called .lower. So it actually looks like this, .lower, and I'm typing it in the correct place here. But what this does is it takes any string and immediately converts it into lowercases. So all lowercases. It takes any letters it has and just puts it to lowercase. So this is really useful because what we can do is we can take the input that we typed in, immediately convert it all into lowercases, and now when we want to check for equality, it doesn't matter what capitalization we used in the string, it will still be true because it'll just automatically go to lowercase. So we could type capital E and that will still, this condition will be true and we'll still do let's play. So in fact, let me show you. So notice I just put .lower here. And guess what? There's actually another method called .upper that we could use as well. And .upper will make it all uppercase. So if we wanted to do this and make this all uppercase and then make this .upper, same thing, right? So I'm hoping this is making sense, but essentially whatever you're going to compare here is going to have to be in all lowercase or all uppercase, and that's going to correspond to whether you use .lower or .upper. All right, so let's run this now and let's see what we get. So what is your name? Tim. What is your age? 19. Do you want to play? Y-E-S. Okay, so we have a capital Y and a capital S, and let's play. That still works fine. So that's cool. I think that's an important method to know. That's pretty quick, so I just wanted to show that to you guys. And now let's actually start building a game. Let's start making something cool, and then we'll implement like maybe a health or some other interesting things into our game that I didn't have in the demo game. So the first thing we want to do is actually I'm going to add an else statement here, and I'm just going to print see ya ... So if they don't want to play, we'll simply tell them, you know, goodbye, like see you later. And then inside of here, if they want to play, so notice I'm nesting all these things, right? Like there's an if and else inside of another if statement. And that's totally fine, because all the if statement says is, well, if this is true, do whatever's indented, and here we are. And then inside here, this if statement says, if this is true, do whatever's indented, right? So we go ahead and do that. So what I'm going to do in here now is I'm going to ask another question, and this will be the first decision that we want to make. So I don't know what I want to make it. I think I'm going to go with the classic, do you want to go left or right, just as our first kind of path. But you guys can make this whatever you want, and feel free at this point to kind of change around some of the stuff that I'm doing and make it your own, so long as you understand what's happening. So I'm going to say left underscore or underscore right equals input first choice ... left or right. Now it might be a good idea in your game to put brackets at the end of your answer and just put inside of the brackets what the user should type. So left or right, because technically, right, they might not know, like they might type I want to go left or I want to go right. So it might be a good idea to just put brackets inside of the prompt, just so they kind of know what options they have, like what they can actually type, right? And then what I'm going to do after this is I'm going to check if left underscore or underscore right is equal to left. This will be my correct decision if I go left. Then what we'll do is we'll print something, or we'll do something. Otherwise, we'll just print out to the screen, you fell down and lost ... You can see I'm not super creative when it comes to making these games, but the idea is I'm just trying to show you how the paths work. So this is like if they lose, so if they decide to go right or they type anything other than left, then we'll print out you fell down and lost. Otherwise, if they go left, then what I'll ask them is another question. So say, okay, if they go left, they're going the right direction. So let's ask them another question. Awesome. And in fact, inside of else, I don't even have to make them lose. I could ask them another question in here too, right? We could make it as confusing, as complicated as we want, and make it really hard for the user to figure out what way they're kind of going, so they have to play the game a bunch of times. So anyways, let's go here inside of left. And let's say, I'm just going to put ANS, that's short form for answer. That's what I usually end up doing as we get longer and longer, rather than making these variable names. But I'm going to say ANS equals input, nice. You follow the path and reach a lake, ... Do you swim across or go around, ? And then inside of here, I'm going to put across as the answer, right? Is that across? I don't think you need two C's, so across or around, just telling them what they can type in, right? And now I'm gonna have to zoom out a little bit just so we can read. Oh, that's better, okay. And now inside of here, what I'm gonna do is I'm gonna check what their answer was, right? So I'm gonna say if ANS is equal to, and maybe we'll say that going across was the correct answer. Actually, let's say going around was the correct answer. So if ANS equals around, then we'll do something. And then we'll say elif, so I'm actually going to switch it up here just to show you something else. Elif, elif ANS equals across, and then else. So the reason I've done this is because what I actually want to do right now is I want to make it so that if they type across or they type around, both options are correct. They can go both ways. But both ways will lead them to different types of decisions, right? So they'll get asked now different questions inside of here. But if they don't type around or across, right, then I want them to lose. So I'm just going to go down here and say print you lost. Again, I don't have really good, like, lose messages, but that's totally fine. And then inside of here in around, what I'm actually going to say is that one of these options is better than the other. So here is where I'm going to implement something that I hope is you guys will appreciate, because it is a little bit more complicated, but I want to show you how we can do something like this. If they decide to go across the lake, I'm going to kind of make up a story and say they got bit by something and they lose health. And maybe we'll put something inside of here that checks, what their health is. So if their health goes lower than 0, then they lose, right? Then they lose the game completely. I think that'll be interesting to do. So let's do something like that. So if I want to keep track of health, right? And maybe we set them off with like default health of 1 or default health of 10 or something, and they lose health, we'll need a variable to store their health, and then we'll need to subtract from that variable. So what I'm going to do is on line 7, I'm going to make a variable called health. I'm going to set that equal to 10. So they could technically have 10 health, and we'll tell them how much health they start with and how much health they lose. So maybe to start, we'll print out you are starting with, and then in this case, comma, the number, and then comma, health. So you are starting with 10 health. That'll print out 10. The reason I put health here instead of 10 is because if I change this number, maybe I change it later to 15, 20, something like that, I want this to automatically update. I don't want to have to rewrite the number 2 times. It's better just to have it stored in one place. So that's why I've done that. So we've defined they have a health. And we'll say if ANS equals around, then, whatever. If ANS equals across, then we'll print something else. In fact, actually, what we can do is something cool here. And I'm going to get rid of the else and just change this a bit. So I'm going to say print, and inside of here, I'm going to put you went around and reached the other side of the lake. And then here I'll print you managed to get across, but were bit by a fish. I don't know, let's just say that. You were bit by a fish and lost 5 health. So I'm going to tell them that they lost 5 health here. And then what I'm going to do is, because they lost health, and I'll put some periods here, is I will say health minus equals 5. So we'll just, remove 5 health from their health. So now they only have 5 health. And now what we can do down here is we can ask them another question, right? And we can keep going. And in fact, what I'll do now is I'll pause and we'll run this just to see where we're at right now. And then I'll just kind of keep going and just coding out my version of the game, just showing you guys some different cool things that we can do. And hopefully you guys take this upon yourself to make your own cool game, right? And change the paths and decisions. And this will be like a really good template for you to figure out what to do. So let's run this and let's go. What is your name? So my name is Tim. I'm 19. Hello, Tim. You're 19 years old. You're starting with 10 health. You're old enough to play. Do you want to play? So actually, maybe I should put the health somewhere else. So this is great. So I tested it. I realized something was wrong. So now I only want to tell them how much health they have, right? If they're older than 18. So in fact, let's get rid of this, telling them what they are. I don't need that anymore. And then after we ask them, do you want to play? We'll print out, you're starting with 10 health. Let's play. And we can leave the health defined up here. Doesn't matter where we have it, but we'll just put it here so that we can access it throughout all of the stuff down here. Great, so let's run this now. And let's zoom in a bit. It says, what is your name? Tim. What is your age? 19. You're old enough to play. Do you want to play? Yes. You're starting with 10 health. Let's play. First choice, left or right. So where should we go? Let's go left. Nice. You follow the path and reach a lake. Do you want to swim across or go around? Let's go across. And it says you managed to get across, but you were bit by a fish and lost 5 health. So you can see that the game is actually working, right? And we'll run it one more time just to test out another path. So Tim, 19, you're old enough to play. Do you want to play? Yes. First choice, left or right. Let's go right. You fell down and lost. Boom. So the game is functioning. Okay, so let's keep going and let's add some more stuff into this. So health minus equals 5. So now they're at 5 health. Now what I'm going to do here is we'll have to do something to check if they are at lower than 0 health, right? So they'll be at some point where they could potentially lose all their health. And if they're at lower than 0 health or they're at 0 health, then we'll have to tell them that they lost. So that's going to be interesting to do actually. But first, let's just ask another question. So let's say ANS equals input. And inside here, what do we want them to do next? Maybe I'll tell them that I'm going to take an example from my previous game. I'll say you see a river and you see a house. Do you go towards the river or do you follow the house, right? Or other way around. Do you go towards the house or do you follow the river? Okay. You notice a house and a river. Which do you go to? And then again, I'll give them what they need to type in here just to make it easy. So we'll say river / house. And make sure we add a space here in between the question mark and the end of the quote, just so there's a space when they're actually typing it in. And now let's check if ANS equals, in this case, house, then we'll do something. Else we'll do something else. So what I'm actually going to say here, this will be kind of an interesting little twist to this game I wasn't even thinking about adding, is if they decide to go to the river, we'll just tell them that they like fell in the river and they lost, okay? And then if they go towards the house, we'll tell them that they went towards the house, but they lost 5 health because like the guy at the house hit them or something. I don't know. I'm trying not to be too violent in these answers. But the idea being that I want to make it so that they can get past this, but if they decide to go across, it will actually end up being the wrong decision because they lose 5 health, right? And then down here, they'll lose another 5, so they'll lose the game. I hope that makes sense, but you'll see as I start coding it. So if ANS equals house, then what we'll say is we'll say print, you go to the house, and are greeted, by the owner, ... He doesn't like you, and you lose 5 health. Why not? All right, we'll just go with that. We don't need any more deeper explanations, and then we'll say health minus equals 5, so we're removing 5 health. Again, that's equivalent to health equals health minus 5, so whatever the value of health is, we'll subtract 5 from it. The reason I wouldn't just set health to 5 or I wouldn't just set it to 0 is because we don't know if they lost 5 health above here, so we need to make sure we just subtract that value. And then else, we'll print down here, you fell in the river and lost ... Okay, so now what we'll do after this, right? So you can kind of see the way that I'm actually, let's see here, managed to get across. So now actually inside of this if statement, sorry, I'm just trying to think of what we're actually going to do here. On line 30, I'm going to check if their health is lower than 0. So if they have lower than 0 health, because this will be the first point in the game where they could potentially be at 0 health if they lost it twice, then we'll tell them that they lost. Otherwise, we'll keep going, right? And then maybe we'll wrap up the game with one more path or something. So we'll say if health is less than or equal to 0, then what we'll do is we'll print you now have 0 health, and we don't need a comma, and you lose the game, ... All right, so there we go. You lost the game. Actually, we'll just do, and you lost the game. All right, so if their health is lower than 0, they lose. Otherwise, then inside of here, we'll say print you have survived. ... You win. I don't know. We'll just say that they win at that point, and I'll show you how we can add some more cool things too. All right, so that pretty much wraps it up. Let's test this game a few times and make sure that everything's working fine. And then we'll add anything we need to. So what is your name? Tim. Let's actually test one if I go like 14. You're not allowed to play. Okay, so let's go again. Tim, 19. Yes. First choice, left or right. Let's go left. Nice. You follow the path and reach a lake. Do you swim across or go around? Let's go across. You managed to get across, but you were bit by a fish and lost 5 health. You notice a house and a river. Which do you go to? The river or the house? Let's go to the river. And you fell in the river and lost. Okay, let's try a few more paths. Just want to make sure this works. But I hope you guys understand the point of this, right? Is to go down like all these different branching paths. And, you know, if you make a bad decision at the beginning, you're going to have to keep going down all the routes until you realize that, oh, no, I should have gone right instead of left, right? So you can make these really intricate. And a lot of people that I've taught to do this before have made really cool games. They're like hundreds of lines of code that take you a really long time to actually figure out. So I think it's pretty interesting. Okay, but first choice, left or right? Let's go left. Nice, you follow the path and reach a lake. Do you swim across or go around? Let's actually go across and let's test out this health stuff. So we go across, and then it says you notice a house and a river. So let's go to the house. It says you go to the house and you are greeted. Oops, I should probably spell that right, by the owner. He doesn't like you and you lose 5 health. You now have 0 health and you lost the game, right? So you didn't technically lose because you went to the because you went to the house. It's just you lost because you lost 5 health, right? And now I'll show you the example where if we don't lose 5 health at the first step, we can actually survive by going to the house. So what is your name? Tim. What is your age? 19. Do you want to play? Yes. Let's play first choice, left or right. So let's go left. Let's say nice, you follow. Let's go around this time. You went around and reach the other side of the lake. You know, it's a house and river. Which do you go to? Let's go to the house. And you go to the health and you're greeted by the owner. He doesn't like you and you lose 5 health. You have survived. You win. So even though we lost 5 health, we still won because in the previous step, we didn't lose 5 health. So I hope that me showing you the health thing gave you some ideas for some stuff that you can do. What you also can do is you can you can do something like let the user pick a weapon or something, right? So a cool example, and I'll just talk about some kind of add-ons now because we're kind of wrapping up the video anyways. You could do something like you can start by asking them what weapon you want. So you could say, you know, weapon equals input, pick a weapon, question mark, or pick a weapon, colon. And then your options could be something like sword, I don't know, maybe like a baton. I'm trying not to be too violent, and I don't know, let's go something like taser, right? So you could tell them to pick one of these weapons, and then based on the weapon they pick, you can say, oh, well, if they have this weapon, then they're able to get past this obstacle. If they don't have this weapon, then they can't. So what you would do if you wanted to check something like that is you'd say if weapon equals whatever it equals, and if it equals that, then boom, they're good to go, right? And they can continue on. Now, the last thing I'll show you, because we have 1 minute left, kind of before I'm planning on wrapping this up, is how you can actually check multiple things on the same line. Now, I'm just going to kind of introduce this to you guys, because then you can kind of look at it yourself. It's pretty easy. There's these things called and or. Now, and or are ways that we can chain conditions together. I'm not going to explain them in depth, but if you do something like true or false, the result of this is true. The reason this is true is because when you have an or, this pretty much says, look at the left side, look at the right side. If one of them are true, the whole thing is true. So if you go ahead and do something like, you know, x, let's say like 5 equals 5, 7 equals 8, then this would be true, right? Because this condition is true, this condition is false. So since one of them is true, the whole thing is true. Now, contrasting that with and. So when you do and, what this does is it checks if both of the things on the left and right hand side are true. If they are, the whole thing is true. If they're not, it's false. So in this case, this would be false because one of them is false. But if I change this to be like 7 equals 7, then this is true. So you can use this and or to actually chain conditions together. So you could check like inside of here, if left or right and, you know, weapon equals whatever, you can do something like that. Oops, so I put this in the wrong. If left or right equals left, oops, and weapon equals whatever it equals right inside of here, then this whole thing will work. So you can check if this whole condition is true or false, and then execute an if statement based on that. So with that being said, I think that's pretty much it. I'm going to zoom out here so you guys can have a look at all of the code at once. I understand this maybe isn't mobile friendly, but at least now you can kind of see what we've actually created. And I really hope that throughout this series, you guys have learned something about Python. You've learned kind of the basics of the language, an if and an else, and I've given you enough knowledge that you now feel a little bit confident to go out there and make some kind of cool game. I will say there's a ton more stuff you can do with this. There's a lot more things to learn. But again, the focus of this series was around building a project, and I really hope that this helped you do that. So with that being said, that has been it. I hope you guys enjoyed. If you did, make sure you leave a like, subscribe, and I will see you in another YouTube video.